What does it mean if a weatherman says that the average temperature today was 72 degrees? Did they just take the lowest temperature and the highest temperature and add them up and divide by 2? Or did they do something else? Um, for instance, if I look at a couple of graphs here, let's suppose the day starts off cold. It it gets warmer, stays warm for a while, and then it cools off to about the same temperature it started with. That might be one day. Um, then there's another possibility that maybe it was cold for quite a bit of the day. It suddenly got warm, it got cooled off again, and then it's back to there. Both of them, I'm trying to make it so that they have the same lowest temperature and the same highest temperature. But yet they're very different types of days. This is generally a warmer day than this one is, and I would hope that this one would have a higher average value. And it does. So in this section here, we're looking at what do we mean by the average value of a function? Um, and there's a couple ways you can look at this. Now, from the general Calc 2 kind of way of looking at it is that, let's cut it into a bunch of pieces and add them all back up together. Well, in fact, finding an average value really is that. If I said, hey, I'm going to sample this day and take, maybe 7 or 8 times, and let's say, how many do 1, 2, 3, 4, 5, 6, 7. So suppose I figure out the temperature at each of these 7 locations, and I add them all up and divide by 7. That might be one way of estimating an average value. Maybe I cut the day up into a whole bunch of pieces and take the temperature at each one of those every minute and then divide by the total number of minutes. That's what we really want to do. We want to say, take the day, cut it up into n equal pieces, evaluate the temperature at any of those times, at all of those times, add them all up and divide by n. In general, it's not just a temperature function that we might be looking at. You've got some function y equals f of x on some interval from a to b. And I want to take that interval and cut it up into a bunch of pieces. Let's call this x1, x2, and so on. At each of those x's, I'm going to evaluate the function. So this is f of x1, and the next one is f of x2, and so on all the way down the line. Add them up and divide by the total number. So, wait a minute, why did that just jump out of the way? There we are. So I'm going to say that the average is approximately equal to f of x1 plus f of x2 plus, and so on, all the way down to f of xn, and then I'm going to divide by n. Okay. And then I want to take the limit as n goes to infinity. Now, I'm going to do a little bit of algebra here to show you something here, that if I cut these into equal pieces, then each piece we might call, how about delta x, which would be b minus a over n. Well, if delta x is b minus a over n, then I can solve for n, where n equals b minus a over delta x. And so I'm going to substitute that into there. So I have my average is approximately equal to, let me just write this way, the sum I equals 1 to n of these f of xi's. And I'm dividing by n, but n is b minus a divided by delta x. Well, dividing by that fraction is the same thing as multiplying by the reciprocal. So I'm looking at this is delta x over b minus a times the sum I equals 1 to n of these f of xi's. Now, this is starting to look familiar, because if I take the 1 over b minus a out in front and then put the delta x times the sum I equals 1 to n of the f of xi's, that looks like a Riemann sum. And so the average value, average G value, is going to equal the limit as n goes to infinity of this approximate average value. And that 1 over b minus a is a constant, so I've got 1 over b minus a, and then this thing with the limit as n goes to infinity is actually just the integral from a to b of f of x dx. Okay. So I think about it first in terms of how do I calculate averages? I take a whole bunch of things, I add them up and divide by however many I have. And then that's what I'm doing, but I'm taking the limit as that number of things goes to infinity, and it turned into this integral. But once I have this integral, I can think of this in a very different way, because what I'm looking at here is that, I'm going to draw the picture again. Here's f of x between a and b. This integral is the area underneath. So the integral is the area. The b minus a is the length of the base here. Why did that just erase? The b minus a is the length of the base. So I have the area divided by the length of the base. If this were a rectangle, if I was looking at a rectangle and I knew the area and I divided by the length, well, that would give me the width, right? Or the height, whatever you want to call it. But this isn't a rectangle, but it's still the area divided by the length. So maybe what it's given me is essentially an average height. Right? If this were a rectangle, if they had the same amount of area under this rectangle, in this rectangle here, as I did underneath the curve, then the area divided by the length would be the height. So this is kind of a geometric way of thinking of what the average value is giving you. If you think of this as water that's being held by like a jello mold underneath this curve, and then all of a sudden you say, okay, let's take that away, take that constraint away and let the water just seek its own level. All the stuff that's up here that's higher than the level would sink down into there, and that area would fill in this area, and you'd end up with this rectangle. The height of that rectangle now is the average value of the function that you started with. That's the notion of the average value. I want to switch to another application here. So here's an example. I have got y equals the sine of x between 0 and, well, pi, close enough, 3.1416. Okay. I want to know what's the average value of that function. Well, it goes up as high as 1 and down as low as a half. My first estimate is maybe the average value is a half. So from 0 to 1, right in the middle would be a half. So I'm gonna take a guess of the average value is here 0.5. Right? So a blue line is drawn across now, and so if you look at this rectangle bounded on the left and right by the red sides, and across the top by the blue one, and the x-axis on the bottom, look at the area of that rectangle and compare it to the area underneath the sine curve. You say, do we have the same thing? Well, I look at this and say, if the area is the same, then the area up here under the curve but over the line should be the same as the area that's over here and there put together, that's under the line but over the curve. All right, again, think of this as walls. The red thing are walls that aren't going to move. If I have water all underneath this black curve, and I suddenly say, okay, take the black curve away and let it go flat, is this area up here going to fill in those spaces, or is it going to be more? Personally, it looks to me like it's going to be more. It looks to me like, you know, if you offered me cookies, say, here, you can have these 2 cookies, or you can have this 1 cookie, this big cookie. I would say I'll take that big cookie. On the other hand, if I say rather than the 0.5, maybe I should, let's guess a little higher, about 0.7. Right. 0.7 now, this area up above is looking pretty small. Again, you know, offer me these 2 cookies versus that one, I'm going to take these 2. So it feels to me like this is too high. At some point, I'm going to get it so that this and those are the same, and I'm not going to be able to tell which cookies I want. So I'm going to, let's say 0.6. At this point, Yeah, this is starting to be tough to tell. Do you want that one or do you want these two? Anyway, what is the actual absolute value? Well, the actual absolute value is determined by this calculation. And I need to uh, move my window down. Can I move my window down? There we go. I'm integrating the y value dx from a to b and then dividing by the length of b minus a. And in this case, it turns out to be 0.6362. So my 0.6 was not too bad. If I go a little bit higher, 63662, you can't really tell that it's changing. But anyway, at this point right here, that height is the average value of the sine curve between 0 and pi.